Hello, this is part two of ordinary differential equations. So we are going to continue with letter I. So in letter I, we have to, the direction says we got to find the order and determine if it's linear or not. Okay, so on I, so let's look at the order. So highest derivative. The highest derivative is this one, dt over dt over d theta, and that's the first derivative. So it's going to be first order. And is this linear or not? So let's look at all the terms. So this one, this is fine. This is fine, even though cosine is not linear, but it has a theta. Um, as long as this letter does not have a t in it, it's fine. So this is actually cosine of theta would work. If it was just regular cosine, no, it would not work. So this it checks out. This one is also fine because this is a power of 1. And also because this theta does not have a t in it, the coefficient does not have a t. This is fine. This is also fine. Yeah, this is sin of 1 plus theta is fine. Uh, yeah, so this makes it linear. Okay, let's look at the next term. So let's look at the order. So we have a dy dx. That's the only derivative I see, and it's first derivative, so the order is going to be first order. And is this linear or not? So let's look at the first term. This has an x, has a coefficient of x, and it's as long as it doesn't have a y, it's fine. This one, this one is fine because this is y to the power of 1, and then if you look at the coefficient, 3x plus 1, as long as it doesn't have a y, it's fine. And then this is also fine. Why is this fine? Is because this is constant. So S, this makes it linear. Okay, what order would this be? We have dr square over dt square equals negative k over r square. Second derivative is second order. And is this linear or nonlinear? So this one has a coefficient of 1, and that's fine. Negative k over r squared, unfortunately, k is a constant, that's fine. But 1 over r squared can be written as r to the negative 2, and this power has to be 1, so this does not make it linear, so this is nonlinear. Okay, what about L? Well, the thing is, you don't see a first derivative, right? But so that you might have to like divide each term by dx. So let's do that. Let's divide each term by dx. Okay, so over here, the dx cancel, so you're left with 2x minus 1 plus 3y plus 7, and then you have dy dx. And then over here, this is going to be 0 over dx. And okay, so now we have a dy dx that represents a first derivative, so it's going to be first order. Then what we got to check if it's linear. This has a coefficient of 1. This has a coefficient of 3y plus 7. It's fine as long as it does not have a y in it. Oh, it does have a y. So it can't have the same variable as the top. So this makes it nonlinear. Okay, letter M. What what I would do is I think the order would be first order because that dp dt is our first derivative. Then what I would do is check if it's linear. I would FOIL out this p first. So this would be p times a. I'll just say it as ap minus what's p times b, p squared. That would be b p squared. Unfortunately, this has a power 2. That makes it nonlinear. Okay. Okay, now let's talk about solutions. So differential form, you're used to seeing this, m of x over y dx plus n xy dy equals 0. So this is almost like implicit form. So for example, we have 4x dy dx plus y minus x equals 0. I would multiply everything by dx. So this is what you get. Okay, so any function when substituted into an nth order of an order ODE, or ordinary differential equation, reduces the equation to an identity said to be a solution of the equation. So now we're talking about solutions. So as you recall, a solution in a differential equation is an equation. It won't be a coordinate like you're used to other like in linear algebra. And you might have a C, right? You might have a C. So general solution to the nth order. Yeah, you can read all that. So you might have a C and you have to solve for C. So that's what it is. So a particular solution to an nth order ODE is one that is free of the arbitrary constant C. So, and then there's initial value problems. I think that's what we're going to do on the next example. Consists of an nth order of an ODE subject to an initial condition. So you'll have like an initial condition. Implicit solution when x and y are intermixed or when y is not isolated. That's like the same thing as an implicit differentiation. We have like different letters on both sides. And explicit solution is when the solution is in the form of y equals y equals f of x. Or sorry, when you get y by itself. Interval of validity solutions where the IVP is defined continuous and differentiable. So that's just basically where the interval is. Okay, so let's do an example to make sense of all this. So example says verify the given function is a general solution of the ODE, ordinary differential equation. So we have 2y prime plus y equals 0. So what you have to do is you gotta they give you the solution. This is your solution. A solution can be an equation, right? And we gotta check, we gotta verify this solution actually is part of the solution of the ODE. So what you have to do is just literally, we have 2 times y prime plus y. We have y already, which is e to the negative x over 2, but we don't have y prime. So that's what you're going to have to do. You're going to have to find y prime. And then hopefully the left equals to the right. So how do you find y prime? So y prime, how do you take the derivative of e to the negative x over 2? It's just e to the negative x over 2 times the derivative of the power. So what's the derivative of negative x over 2? Negative 1/2. So that would be negative 1/2 e to the negative x over 2. Okay, so now let's check. So it's 2, and then you replace y prime with this whole thing. and then plus y is e to the negative x over 2 equals 0. FOIL this out, this would be 2 times negative 1/2, that's negative e to the negative x over 2 plus e to the negative x over 2. Is that equal to 0? Yes, it does. Negative 1 e to the negative x over 2 plus 1 negative x over 2 just cancels and becomes 0. So this just proves that this is the solution of the ODE. Okay, letter B. So they give us a solution of this, and we gotta verify. So what we need to do is find y prime and y double prime. We already have y, right? So let's find y prime. So do you see the C1 and C2? Those are constant. So you could, when you take a derivative, you could just take it out for a bit, and then when you take the, and then bring it back in. So what I mean is we have two terms. This is the first term, and this is the second term. So let's look at how do you take the derivative of C1 e to the x. So C1 is a constant, so take it out, and then just take the derivative of e to the 2x. The same thing here, x times e to the 2x, you're going to have to apply the product rule, right? So C2 is a constant, and then just take the derivative of x e to the 2x, e times e to the 2x by applying product rule. Okay. So let's do this thing here. What's the derivative of e to the 2x? That is e to the 2x times the derivative of the power, which is 2. And then you could bring down the C1, so that would be what's 2 times C1? That's 2C1 e to the 2x. Plus, now how do you take the derivative of x times e to the 2x? You apply the product rule. So what's our f and our g? So my f is x, and my g is e to the 2x. F prime is 1. G prime is, the derivative of e to the 2x is 2e to the 2x. Okay? So if you call product rule is f prime of g plus g prime of f. So what we're doing is this part right now. So f prime is 1. G is e to the 2x plus g prime, which is 2e to the 2x times f, which is x. Put it all together, 1 times e to the 2x is e to the 2x. And then 2 times x, that's 2x e to the 2x. And then we still have this constant C2, so we kind of have to like distribute it. So if I kind of distribute it, this would be C2 e to the 2x plus, if I fill this out, this would be 2C2x e to the 2x. And then you still have this 2C1, so that would be 2C1 e to the 2x. I'm going to kind of rearrange it. I'm going to say y prime is 2C1 e to the 2x plus 2C2x e to the 2x plus C2 e to the 2x. So I just rearranged it. You can leave it like this if you want. So this is my y prime. I'm going to box it because I'm going to probably need it. And then I also need to find y double prime. So y double prime is the derivative of this. So this is pretty easy. Like y double prime. Well, not, we know that if you look at this term right here, we know that the derivative of e to the 2x is 2e to the 2x, and then you have an extra 2, so that would be 4c1 e to the 2x, right? And then we know that the derivative of the second term, this whole thing, I know that 2c2 is a constant, right? So all we got to do is take the derivative of x times e to the 2x, which we already did before. X times e to the 2x is this whole thing. And then if you distribute the 2, that would be 4x c2e to the 2x. And then the derivative of e to the 2x is 2e to the 2x. So if you put it all together, it's going to be plus 2c2 e to the 2x plus 4x c2 e to the 2x plus 2c2 e to the 2x. So if I kind of clean this up, y double prime is going to be 4c1 e to the 2x plus 4c2x e to the 2x plus 4c2 e to the 2x. Okay, now we got to check it. So we got to put it back here. So y double prime is that. So, okay, so we know, so put it back here. Y double prime minus 4 times y prime plus 4 times y should equal to 0. So let's see. So that would be 4c1 e to the 2x plus 4c2 x e to the 2x plus 4c2 e to the 2x minus 4. So minus 4 times y prime. So y prime is going to be 2c1 e to the 2x plus 2c2 x e to the 2x plus c2 e to the 2x plus 4 times y. So that'd be plus 4 times y, which is c1 e to the 2x plus c2 x e to the 2x. Okay, if you clean this up, eventually the left side does cancel. So the left side will become 0, and then the right side is 0. So that is true. Okay, let's see. Let's do C. So we have y equals e to the 3x cosine of 2x, and then we have to make sure it's, here's our differential equation, y double prime minus 6y prime plus 13y equals 0. So we already have y, we don't have y prime, and we don't have y double prime. So so y is e to the 3x cosine of 2x, and then y prime, how would we take the derivative of this? Yes, if you use the product rule, we do. So my f is e to the 3x and my g is cosine 2x. So let's see here. Product rule is f prime of g plus g prime of f. So if f is e to the 3x, f prime is 3e to the 3x, and g is cosine of 2x. G prime is -2 sin of 2x, right? You just apply the chain rule. So when you put it all together, you're going to get y prime equals to 3e to 3x times cosine 2x, right? Plus -2 sin of 2x times e to the 3x, right? And you'll get y prime is -2 e to the 3x sin 2x plus 3e to the 3x cosine of 2x. I'm going to box it, so this is my y prime. Y double prime, so how do you take the derivative of this? This, you have to apply product rule. This one, you have to apply product rule. When you put it all together, I'm not going to do the algebra. You can do the algebra, but when you do all, because you just apply product rule, right? That's not too bad. So when you do the algebra, you get y double prime is 5e to the 3x cosine 2x minus 12e to the 3x, and then sin of 2x. So if you have to do the algebra, that's fine. But that's what I got as my y double prime. Okay, now you got to check. It's y double prime minus 6y prime plus 13y equals 0. So y double prime is this, so that's going to be 5e to the 3x cosine of 2x minus 12e to the 3x sine of 2x minus 6y prime, which is -2e to the 3x sin of 2x plus 3e to the 3x cosine 2x plus 13y. Okay, so you kind of clean this up, you're going to get 18e to the 3x cosine of 2x minus 18e to the 3x cosine of 2x equals to 0. Everything cancels, right? So you get 0 equals 0. So that's true. Okay, one last one. Okay, so we have y equals 1 over 4 minus x squared, and we got to find what, and the differential is y prime equals 2x y squared. So let's see if this is actual solution. So we have y, but we don't have y prime. So let's do that. What I would do is, I don't want to do the quotient rule. What I would do is rewrite this as I would rewrite this as parentheses 4 minus x squared to the -1, right? And then I would just take the derivative from there. So the derivative, how do you take the derivative? Use power rule and chain rule. So -1 times this coefficient is 1. So 1 times -1 is -1. Leave the parentheses alone. And then the power is going to be old -1. So -1 minus 1 is -2 times the derivative of the inside. So the derivative 4 is 0. The derivative of negative x squared is -2x. -1 times -2, x is positive 2x, 4 minus x squared minus 2. And then just simplify this. So this is going to be y prime equals 2x over 4 minus x squared squared. Okay, now we got to verify it. Oh, is there anything? I got to find, before I go further, I need a y squared. So we don't have that. So let me find that real quick. So y squared is going to be 1 over 4 minus x squared all raised to the second power. So that would be 1 over 4 minus x squared squared. I'm just going to leave it like that. I'm not going to FOIL it. So let's verify it. So y prime is 2x over 4 minus x squared squared equals 2 times x. I don't know what x is. I'm just going to leave it. Times y squared, which is 1 over 4 minus x squared squared. Okay, so if I FOIL this, 2x. 1 times 2x is 2x over 4 minus x squared squared. Does this make it true? Yes. Okay, so that is the answer for letter D. Okay, so this was basically an introduction of ordinary differential equations. So I'm going to stop here.